Hello everyone, welcome back to my channel. In this video, I'm going to show you one of the best antenna array analyzer application.
Alright, here I'm going to try to install the app onto a used iPhone 4 which I've purchased on eBay. I'm going to use iFunbox, which is a freeware. Here I'm going to make sure I'm connected to the iPhone 4S, and then I will hit on the file browser, select that device and install app, and selecting the IPA file, and it's doing the installation now, and it says 1 succeeded, 0 failed. Alright, let's see whether the app has been installed successfully on the iPhone 4S. There it is. Let me try to launch it. Well, it's asking me to sign into iTunes, so let me sign in with my Apple account. Okay, let's launch it. Oops, it's not working for some reason. The iOS is 9.3.5. I believe that should work, so let's try again. It's working now. So 9.3.5 does work. It didn't work just now because the other apps were open. Alright, here I've launched the Antenna Array Analyzer app, and let's tap on Start to begin. But before that, let me say that this app is a very resource intensive app, and if you are running other apps, you need to close the other apps on your iOS device, otherwise the app would hang intermittently or it would not even launch at all. Now let's tap on Start to begin. This is the first page that it will show you, and if you look at the bottom menu, you will see there's 3D pattern, 2D pattern. These are the two different types of simulations, and then there's the antenna type, the array, and also the calculator. So first of all, let's go to the calculator to set our frequency of interest. As you all know, I'm interested in FPV, so the frequency I'm using will be 5.8 GHz. That will be the video frequency for FPV. So let me set that to 5.8. And then now the wavelength has been calculated. Same goes for the half wave, the quarter wave, and the wave number. You'll see the other measurements as well over here. And relative permittivity refers to the dielectric of the substrate. A substrate would be something like the PCB board if you're building a PCB based antenna. So let me set that to FR4 because FR4 is the type of PCB that I use to build my antennas, and that is affordable and you could find them easily. If you watch my previous video, the relative permittivity for 5.8 GHz for FR4 PCB is 4.22. Alright, now that we are done, we could start to go to the antenna type. At the antenna type menu, this page here is the isotropic antenna. The isotropic antenna is just a model, so it can't run any simulation as stated here. So let's look at the other antenna types that we could run simulations on. The second one is the short dipole. It's interesting that over here you could set the polarization, whether it's vertical or horizontal, by changing the X value. And interestingly, the length of the antenna is locked, so you can't change that. Now let's go to the long dipole. Okay, now you can change the length for the long dipole, and you can set it to quarter wavelength or half wavelength or even full wave if you have enough space to run a full wave antenna. The next antenna type will be the horn antenna. This is interesting. This one here has a pretty high gain, and we don't see anyone using it for FPV, basically because I believe it's a linear polarized antenna, so it doesn't have a circular polarization. But it would be interesting to build one for long range and then pair it with a linear antenna, like a rubber ducky antenna, on the video transmitter on your drone. The next antenna here is the microstrip patch antenna, which is really important, and it allows you to set your dimension, W and L as stated here. So using the default values, let's run a simulation to see what kind of beam pattern we get for FPV for 5.8. Wow, this is the directivity, and you can set it to gain and this is the gain pattern. So the gain is pretty high, as you can see, it's 28.9 dB, but the directivity is not what we are looking for. There are various null spots, which is no good for FPV. So let me change the measurement. Let's go back to the antenna type. Oh, wait a minute, I'm not sure if the simulation just now is for a single antenna or is it for an array. Let's go to the array to have a look. Well, that simulation that we saw earlier was actually for a 5x5 array, so we have to change that to one single antenna. So I'll change it to 1 by 1 by 1. So there are 3 axes, so 1 by 1 by 1 is a single piece of patch antenna. Let's get back to the 3D simulation pattern and see what we've got. Alright, it looks different now, but still there are null spots. Let's take a look at the gain pattern. Wow, look at that. Looks pretty interesting. But we want a radiation pattern that is without null spot. So let me change that by setting the dimensions. Let's get to the antenna, and let me see if I could set it to a full wave of 5.8 GHz, and that would be about 51 mm. That's the wavelength of 5.8 GHz if I remember correctly. So now we have a square which size matches the 5.8 GHz full wavelength. Let's do a 3D simulation pattern. Wow, look at that. Directivity looks like this. So if you're flying FPV, your drone is going to lose signal if it flies to here and here. Not very good, so let me set it to a different measurement, see what happens. We try to reduce the L value to maybe 28, so it will be like a rectangle patch instead of a square. Let's run the simulation pattern now to see what I've got. Wow, it's not too bad. Let's take a look at the 2D pattern. For the 3D pattern, if you look at the XY, this is the direction of the beam. Okay, this is what we look at usually from the top view. And if you look at this, it's not too bad, but the beam isn't wide enough. So I'm going to play around by changing the dimension some more. So if I increase this to say 35 and see what happens. Wow, now I'm losing energy at the side. That's no good. So I'm going to change it back. It was 28 earlier. Let's see what happens if we reduce 28 to say 20. Wow, now we have a wide beam. This is good for FPV. But the wider beam does come with a sacrifice on the gain. If we look at the gain, it's 9.7. Okay, so 9.7 with a pretty wide beam. If we change that back to 28, now we have a narrower beam, but the gain is now 11.6. So it depends on what you want. If you are flying long range, you will go for higher gain and narrow beam. But for all round flying, I think I'm going to set it to a wide beam. So I'll go with 24. Yep. That's pretty much the kind of beam that you get with 4 turns or 5 turns helical, and gain is about 10.7. which is pretty good. Okay, now that I'm happy with the dimensions of a single patch, let's try to do a pepper box. You know, like IB Crazy, he has an antenna which are basically two crosshair antennas paired together in a 2x1 array. So let's do that. So now we have 2x1, so that means we have a pair of patch antennas. And spacing is important. Spacing would be not more than a wavelength, so one wavelength would be 51 mm for 5.8 GHz. Let's see what happens if we space it by 51 mm. Wow, look at this. Okay, now we have a much stronger antenna. The beam is 13.4 now, because we have a pair of patch antennas instead of a single one that we had earlier. I'm not happy with how the side loops here are formed, so I'm going to change the spacing. I'm going to reduce it to half wavelength. So let's see, 25. So 25, I don't have to change this actually because there's nothing at Y, so just keep it at 0. Right, so 25 is half wavelength apart, and let's get back to run a simulation. Wow, look at that, this is good. This is a very wide beam, just like IB Crazy's Pepperbox antenna. And of course the wide beam comes with a sacrifice, so you get a wide beam at the horizontal axis, but the beam for the vertical axis, the elevation, is now reduced. So this is good for low altitude flying. And to look at the patch antenna, we could turn on this. There's our patch there in the middle. So basically, if you look at my previous video, I show you how to make microstrip PCB with just a computer and couple of FreeOS. Now with this antenna analyzer software, you could basically design your own powerful microstrip antennas. This is an array of 2. We could have an array of 4. So a quadruple array would be 2 by 2. I will have the same spacing for the y-axis now. Let's run a simulation. Wow, look at that. The gain is 13.3. It is wider for the horizontal axis, but you could position the antenna in landscape instead of portrait orientation if you like. So once again, it depends on your style of flying. Here we have it. This is a quadruple array of 4 microstrip patch antennas. Let's get back to array. There are a couple of different arrays. Some are 3-dimension, like this one here. So you could set number of turns. It's like a cylinder, so you have number of turns, like a helical. And with each turn there are elements. So you can have 10 elements. And then this one allows you to set the radius. Unfortunately, the simulator does not have one for a helical antenna. This one looks like a pentagon. Yeah, so you could set your own spacing and the number of elements on the x-axis. And the grid will be what I'm using. The other interesting thing to have is the degree. So if you're doing beam forming, like you want your antenna to form beam in a specific pattern. For example, if you want the beam to always sweep to the left, you could have delay. So by setting delay, it's like a phase shifter. You could delay each you could delay each antenna in your array, and then the delay will cause the resultant beam to steer to the left or to the right. And this is interesting if you're working on phase shifter arrays or phase arrays. This is the one that I pick on, which is this 5 elements, 5 by 5, 5 antennas. And there's a play button here basically. Oh, look at this, this is crazy. This is like 5 by 5, this is like 25 patches, and the gain is close to 20 dB as you can see here. You can hit on play and it will rotate. And we could change it to like a skeleton model. And you could see the antennas more clearly now if you set it to opaque mode. And yeah, basically there's also the normalized intensity if you know what the value is. And there's an email function here to email to yourself the report in text format. This is a pretty cool software as we can see now, and it's really useful if you are building antennas, especially for FPV. And speaking of circular polarized antennas, if you build like a patch antenna like this one, and if you set the degree to 90 degrees delay for the second antenna, so let's say we have 2 by 1 by 1, that's our pepper box antenna, the 2 antennas array of the microstrip patch. So the microstrip patch here, we have 2 of this, alright. And I did mention that this software doesn't support circular polarized design, but you could actually program it if you want to. So we have 2 of this, and if we delay one of the 2 by 90 degrees, we can induce circular polarization. And what we can do here is we could set the delay to 90, and with that you have circular polarization. (12 dB gain, directivity). There we go. I'm gonna share the IPA file which I found on my computer. A lot of people have been asking me for the app, and I kept replying that I can't find the app anywhere on the Android Play Store, and for the Apple users is no longer available on the App Store. So by posting the link to the IPA file, I hope you guys are able to somehow find a way to install the IPA file. I guess you have to find an old iPhone with iOS 8 or below, because when I upgraded my iOS to iOS 10, the app doesn't run anymore, and now I have iPhone 7 and the app is there but it could no longer launch. That's all I have for this video. This is something that I like to share, and really I hope you guys will be able to find a way to install the IPA file on your iOS device and have fun with this app. Thank you for watching, and see you again.